In this video, we'll practice finding areas by integration. Here's our example. Find the area bounded by y equals 3 minus x, y equals root x minus 1, and y equals 0. Let's make a table of values for the first two curves, and then we'll be able to sketch the area. For the first curve, y equals 3 minus x. Let's think about some x and y values. Let's look at the x values 0, 1, and 2. When x is 0, y is 3. When x is 1, y is 2. And when x is 2, y is 1. Next, let's think about that square root function. We could plug the x value 1 in here. Y would be root 0, which is 0. Plugging in the x value 2, we'd get y is equal to root 1, which is 1. And then another nice choice of x would be something like 5, because then we'd have y equals root 4, which is 2. So that should give us enough information to sketch the area. So our first curve, y equals 3 minus x, has the following points on it: 0, 3, 1, 2, 2, 1. And if you wanted a fourth point, it turns out that 3, 0 is also on that line. So here we have this line here. For the second curve, we've got the points 1, 0, 2, 1, and then 5, 2. So that would be about there on our sketch, and we're getting this sort of shape for the square root function. Now let me just extend both of these curves here just so we've got an accurate sketch. There we go. And then our third curve here, y equals 0, remember that's the x-axis. So you've also got this third line here that's bounding our area. So here's what our area looks like. Now in terms of calculating the area, we either want to take horizontal or vertical slices. Vertical slices are possible in this area, but they're inconvenient because when we look at this area, the top curve is changing. Over on the left side, we've got the square root function that's acting as the top curve, and then on the right side of the area, it's the line that's acting as the top curve. So vertical slices, inconvenient here. Horizontal slices are going to work a whole lot better. So let's just draw a picture of a little horizontal slice there. Taking horizontal slices means that we're going to be integrating with respect to y, so we need to figure out what y values we'll be integrating over. If we look at our area, the smallest y value that we see in our area is 0, and we'll be going up to y equals 1. Next thing we need to do is to get both of our curves in terms of y. So let's look first at this square root function. It has the formula y equals root x minus 1, and we actually want to solve this for x to get an expression in terms of y. So we'll square both sides. Y squared is equal to x minus 1, meaning y squared plus 1 is equal to x. Let's rewrite this the other way. X is equal to y squared plus 1. Since that is forming the boundary of the left half of that area, I'm going to call that x1. So x1 is equal to y squared plus 1. So I'm going to take all this work that we just did here, I'm just going to recopy it up over here so that we can see our work progressing in a logical way. So now let's look at the line that's forming the boundary of the right side of our area. It has formula y equals 3 minus x, and we'd like to get x in terms of y. So let's write x plus y is equal to 3, x is equal to 3 minus y. And since this is forming the right-hand boundary, let's call that x2. So now to get our area, we're going to be integrating the area of this horizontal slice here. Its area is going to be x2 minus x1 times dy. And since we're integrating with respect to y, we'll be integrating through values 0 to 1. Let's plug in x2 and x1. We've got area is the integral from 0 to 1 of 3 minus y. And then we need to subtract off all of x1, which is y squared plus 1. And that entire expression is going to get integrated with respect to y. So area is the integral from 0 to 1 of 3 minus y squared minus 1 integrated with respect to y. So we just have to be a little careful about the signs here. And we can simplify that before integrating. We've got the area from 0 to 1 of 2 minus y squared integrated with respect to y. Now doing our integration, area is 2y minus y squared over 2 minus y cubed over 3, and we'll evaluate at 1 and 0. Plugging in, area is equal to 2 minus a half minus 1/3. So that's our value at 1, and then we subtract off the value at 0, which is 0. So our area then, if we put everything over 6, it's going to be 12 over 6 minus 3 over 6 minus 2 over 6. Final answer, area is equal to 7 over 6. And if we look down at our sketch here, that seems like a perfectly reasonable answer.